Hello everybody! Today we're going to talk about standard 1.4 additional problems. So we're going to kind of cover problems that we on the sheet that I gave out today. Now what I'm going to do is I'm going to start these problems for you, and then the part where you have to check numbers, what works and what doesn't work, I'm going to leave that up to you. But I want to, the hardest part is doing the fence lines, okay? So to start out this problem, what we want to do is the first step is to find out what x has to be in order to we don't want the bottom to equal 0, so what we're going to do is we're going to take the denominator, x squared minus 1, and set that equal to 0. Okay? So, and then what I notice is if I factor this, I would get x plus 1, x minus 1 equals 0, which means x cannot equal, should not equal negative 1, and x cannot equal 1. Okay? So if I draw this up, that is a pretty darn straight line, if you gotta ask me, especially from a computer standpoint. We're going to have a standard, we're going to have a fence line at 1. So if I'm going to draw my tick marks here, let's make those a different color. Yeah, let's do that. How about red? Okay, so I know that x cannot equal those numbers right there. Okay, so I should have probably write this other one in here. So this would be negative 1, so x cannot equal those two numbers written with the red lines there. Alright, so the next thing we got to do is we're going to set this thing, we're going to change this inequality so it says equals 0. So we're going to have x squared minus 25 over x squared minus 1 equals 0. So now I got to solve for x. So what I'm going to do is I'm going to multiply both sides times x minus 1. If I do that, or x squared minus 1, if I do that, x squared minus 1 times x squared minus 1, we're going to get 0 on this side. So we're left with x squared minus 25 equals 0. And so if we factor this one, we would get x plus 5, x minus 5. Okay? So those also are tick marks at 5. Let's see, 2, 3, let's see, that's 2, 3, 4, and 5. So we also have a tick mark at 5, and we also have one at negative 5. Negative 2, negative 3, negative 4, negative 5. That's a bad looking negative 4. There you go. Alright, so we have those tick marks there at those, and because it's equal to, I'm just going to draw those in a different color, because it does, x can equal those negative 5s and 5. Alright, so now what you would do is now you test out a couple points. I'm going to do one as an example, but we're going to test out 0. So if I plug 0 into this original equation, let me clean this up a little bit. Let me erase all this stuff. Hopefully you caught on to what I was doing there. I think my face might be getting in the way of my problem over here, and I apologize. What's wrong? Gosh, it's almost like I got to move this thing up here. All right, so if we do this, now what we're going to do is test out one of these points. We're going to take this original equation, and I'm going to throw in 0 into it. So 0 squared minus 25 over 0 minus 1 is greater than or equal to 0. Now if I test that out, let me erase this other stuff here. If I test that, I should get determine whether that's a true statement or not. So if I test out one point within this segment, I would get a possible answer. So this would be negative 25 over negative 1. Is that greater than or equal to 0? I would agree, because that is 25. So that means that in this section right here is a possible solution, or there are solutions in this section. Okay, and so then we would test another point, and we test another point, and then we test all these points. So you would have to test a set of 1, 2, 3, 4, 5 different little areas to see if it is solutions. Now we learned today that there is a technique on the calculator that you can do that if you need more practice with that, we're going to talk more about this tomorrow. So again, I'm just showing kind of the basic way to solve the finding the fence lines. Okay. Alright, so on this next problem, this is a problem that doesn't quite have the same, it doesn't equal 0 or have 0 on the left side, and so here we go. I apologize. I gotta get a bigger eraser. This eraser is way too small. Unfortunately, I haven't figured out how to make this thing bigger. So here we go here. If I do this problem here, I would I first want to figure out what would make this equal 0. So I take this 2x minus 1, and I set it equal to 0. I add 1 to both sides. 2x equals 1. Divide by 2. So we get x equals 1/2. So x cannot equal 1/2. Let's put that up here. X cannot equal, I don't think I need to back up my system here. X cannot equal 1/2. Okay? So I got that figured out. Now what I'm going to do is I'm going to change that equal sign or that inequality into an equal sign and solve. This is important. Okay? This is the part we're kind of missing here. Okay? So what I need to do is take negative 7x minus 10 over 2x minus 1 is equal to negative 2. Notice how I switched the inequality to an equal sign, and now I'm going to solve it. So I'm going to take both sides times 2x minus 1. Okay, then I have negative 7x minus 10 is equal to negative 4x plus 2. Then I'm going to add 4x to this side, add 4x to this side. You guys are kind of veterans at this, so this is just me being formal. That's 10, negative 3x equals 12, so x equals negative 4. So I have x cannot equal 1/2, and x equals negative 1/4, or negative 4. Okay, so now I'm going to erase all this stuff just to give myself a little bit of room. And my face is in the way. Gosh. Figured out a way to make that window smaller. Alright, so now we have our boundary lines, and now I'm going to test a couple different points here. Like I said, on the calculator I showed you guys a quick way of doing this to make it so you don't make any mistakes, and but really the only mistake you can make is if you type it incorrectly. So what we have here is we have a fence line at negative 4. And 1/2. So we have a fence line at this particular mark right here, okay, at 1/2, and then I have another fence line at negative 4. Okay, so now what we want to do is we're going to test this. Okay, we're going to pick out a number in this segment right here. I'm going to pick out 0. So if I test this, I'm going to have negative 7 times 0 minus 10 over 2 times 0 minus 1 is greater than or equal to negative 2. Well, in this case, it would be negative 10 over negative 1 is greater than or equal to 2. I would say that's correct. 10 is greater than 2. So this is a solution to this particular problem. Everything that includes 0 inside these little fence lines here. And now what I want to do is test these other ones. So again, the video is getting a little long, so if you understand what you're doing, you can kind of stop me from going any further. You have control over what I do here. 2 over 1 minus 1, so that would be equal to, let's see, negative 17 over 1. Is negative 17 over 1 greater than, oops, I apologize, it's greater than or equal to 2? I would say no, go there. So 1 does not work. Anything on this side does not work. Okay, so now you're going to test this side and see if that works. Okay, now make sure these have to be in interval notation. So that's a very important thing that we learned in the last section. I apologize if this video went a little long, and mostly because I got to erase every time. But thank you very much for your time, and please come with your questions tomorrow. Thank you.